Hello everyone. In this video, we are going to review subtopic 2.1, the states of matter. In this subtopic, we are going to discuss the particle theory, the states of matter, changing of states, and diffusion. What is particle theory? Particles theory explains that all matter is composed of small particles, be it atoms, molecules, or ions. The theory also explains the properties of the different states of matter. For instance, particles are attracted to each other. They are constantly moving, and particles at higher temperature move faster than particles at lower temperature. To explain the properties of matter in details, you just need to memorize D.E.A. In this case, D is for the distance between the particles, E is for the energy of particles, and A is for the arrangement of the particles. To summarize, matters exist in solid, liquid, and gas. In solid, the particles are arranged in a regular pattern and close together, while in liquid, the particles are arranged irregularly, but they are still close together. In gas state, the particles are arranged randomly and far apart. We can relate the arrangement of the particles with the forces between the particles. For instance, the forces of attraction in solid is very strong, which keep the particles to be very close to each other. In contrary to that, in gas, the forces of attraction between particles are non-existent, since the particles are kept far away from each other. In solid, the particles can only vibrate to and fro, but not move apart, which is why a solid has a fixed volume, thus its volume will not change, whereas in liquid, the particles can move around and slide past each other, which is why a liquid can be poured. In gas, the gas moves freely, thus the gas can be pushed into a much smaller volume. We have reviewed the properties of the three different states of matter. Now, we will see how these states can be changed to and fro. The question is, how does it happen? The key point for this question is heat. Either the heat is gained or absorbed or lost to the surrounding. Let us see an example here where we have the changing states from solid to liquid to gas, and we have the process melting and boiling taking part in the changes. During these processes, the particles absorb heat. As they continue absorbing heat, they will start to move faster. When they gain enough energy, they will overcome the forces of attraction between them and started to move apart from each other. Vice versa in the case where gas is changed to liquid and then solid, where the process of condensation and freezing take place. In this case, the particles will lose their heat energy, taking over the forces of attraction and started to move closer to each other. We can see the changes of the states in detail in the heating curve for water. We shall start with the state of solid. At the beginning of the heating, the temperature keeps mounting. The vibrations get larger and stronger. The solid expands a little. The temperature will keep on mounting until a fixed temperature that we call it as a melting point. Here, we shall have a mixture of solid and liquid. The vibrations get stronger, structure breaks down, and the solid melts to a liquid. As the heating continues, the remaining solid in the mixture solid and liquid will eventually change into liquid. In this phase, the particles take more heat energy and they move more. The solid expands a little. The temperature will keep on mounting until a fixed temperature that we call it as a boiling point. Here, we shall have a mixture of liquid and gas. The particles gain enough energy to overcome the forces between them. They escape. liquid evaporates to a gas. As the heating continues, the remaining solid in the mixture, liquid and gas, will eventually change into gas. In this phase, all particles gain energy to escape, and liquid boils to a gas. Now the question is, why are there two fixed temperatures in between these changes of states that we call as melting and boiling point? During these fixed temperatures, the forces of attraction between the particles are overcome as it turns into a liquid during melting point and liquid to gas during boiling point. Now, let us talk about diffusion. What is a diffusion? Diffusion is a process which involves the movement of particles from a region of higher concentration towards a region of lower concentration. It does not take place in solid, and diffusion in liquids is much slower than in gases. In the Brownian motion, we can see clearly what happens during the diffusion in gases where the particles collide with many others. Let us see the experiment to investigate the rate of diffusion of two gases, ammonia and hydrogen chloride. In this experiment, a cotton wool is soaked in concentrated hydrochloric acid, producing hydrogen chloride gas, while the second one is soaked into concentrated aqueous ammonia, producing ammonia gas. Both of the cotton wools are simultaneously inserted into the opposite end sides of the glass tube. After a while, the particles from ammonia and hydrogen chloride travel from each side of the glass tube. In the middle of the tube, they combine to form a white cloud of ammonia chloride. The white cloud forms closer to the right-hand end, so the ammonia molecules travel faster than hydrogen chloride. That's because they are lighter. We can see here that the relative molecular masses for ammonia is 17 and hydrogen chloride is 35. That's the end of the subtopic 2.1. Should you have any questions, please do not hesitate to ask. We shall be discussing the subtopic 2.2, separating and purifying substances, in the next video. See you!